All right, so on Monday, we learned how to evaluate these using the change of base formula. And here's what they wanted us to do. We also learned about properties of logarithms to expand in that. Looking at this up here, can I rewrite 60 with a 5 and a 12? How? 5 times 12, good. What did we learn on Monday about multiplying two things together and expanding the log? Add them, correct. So here's what they wanted us to do. They wanted us to rewrite 60 as 5 times 12, okay? And according to our properties or rules of logarithms, we can rewrite this log base 2 of 5 times 12 as log base 2 of 5 plus log base 2 of 12. Okay? So we can expand it. That's expanding, changing multiplication to addition, changing division to subtraction. Okay? So they wanted us to add these two answers in. 2.32 times 3 or plus 3.585. So 2 plus 5 is 7, 2 plus 8 is 10, carry the 1, 4 plus 5 is 9, and 2 plus 3 is 5. Okay, so that's the answer. Now, we also learned on Monday that we could put this in the calculator, the change of base formula. Okay, which means to do what, Caleb Collins? How do I put this in my calculator using the change of base formula?
Yeah.
What's on those last 5 or 6 problems on your homework that you did? What did you write?
Solve them, right?
What did you write? You just didn't put it in your calculator. Help him out, Cole. What am I putting in the calculator for this problem? Yeah, what fraction? Log of what over log of what?
60 over 2.
Thank you.
Caleb? I was hoping you. Yeah, I couldn't stand it.
The base goes where? Bottom, the basement. Isn't that what we said? Right? Base goes in the basement. So, when I put that in my calculator, log of 60 divided by log of 2, and you could use natural log of 60 divided by natural log of 2 if you wanted. Always just use base 10 one, the common log. Log of 60, just make sure you close it off. Whenever you hit log, it starts a parenthesis, close it off, divided by log of 2, close it off. Is that 5.907? Yeah. So, do you really have to do it this way anymore? No. Just use the change of base formula. Okay? So for number 2, we're just going to do what? Log of what? Over log of what? 1 over 144. And the base goes in the basement, right? In the bottom. All right, so you just do that, and you'll get, and what did they want us to do? They wanted us to write this as 12 squared to 144, and then, add them and then divide, subtract them and stuff like that. But we don't need to do that, okay? So, again, log 1 divided by 144, close it up, divided by log of 2, close it up. All right, negative 7.17. Okay? So, That's how we do those. And that's how we do these also, right? These bottom four. Okay? Any questions on that? All right, the answer to number 3, if you did it, is 1.059. Number 4 was 9.492. Let's just do number 14, the rest of those two, that's calculator stuff. 14 is 2.579. 15 is 2.587. 16 is negative 0.417. And 17 is negative 1.285. Again, it's all calculator work now. Change of base rule. All right? So even the ones we did on the quiz last week, we don't have to do by hand anymore, right? All right. Expanding. This is multiplication, 10 times x, right? So we can write it, expand it to 2 logs by doing what? What did we just do up here for multiplication? Do addition, right? Now, all of you should know this answer. What's log of 10? 1, good. So you should do that one. All right, that's it. 1 plus x. I'm sorry, 1 plus log of x. Forgot my log over here. All right, natural log, this is multiplication here. So this is natural log of 2 plus natural log of x to the 6th. What did we say we had to do when we're expanding? What's the rule? Put it in front of the natural log or the log. Right, so this is log base, sorry, not log, but natural log, sorry, of 2 plus 6 times natural log of x. That's expanded. We have two terms in our natural log, so we have to expand it to 2 terms. Okay? Here we have 3 terms. We got an x to the 4th, a 3, and a y cubed. All right, so we have to expand it to 3 terms. All right? So this is log base 3. Again, the base part stays the same of x to the 4th minus log base 3 of 3y cubed. All right, what do we got to do with that for? Just like we did with the 6, put it out front. So it's 4 times log base 3 of x minus, and then since there's 2 things in here, and it's multiplication, what do I do with those? We add them. Now, we should know this one. If those are the same number, just like these were the same number, this was a 10, we just don't write it. What's the answer to that? Come on. Wake up. 1, thank you. What's this minus sign do to this one? Thanks. What do we do with this 3 for the cube part? Wendell, pay attention. Put it out front. What's this negative do to that positive? Makes it negative. There's our answer. Expand it. Monday. What did we do with 4th root? What did we do last week when we had 4th roots? What power is it? Not 1/4. To the 1/4 power. AJ, pay attention. These are the same thing. Okay? What's the rule for the 3 and the y squared and that 1/4 exponent? What am I supposed to do with their exponents?
You make them.
Who said it? Multiply them. Thank you, Spencer. The birthday boy is on it today. All right, so this is natural log of 3 to the 1/4 plus natural log of y. What's 2 times the 4th? A half, right? What do I do with that 1/4 and 1/2 and when I'm expanding? Move them
Down.
out front, right? Just like we moved this 3 out front, right? And just like we moved this 4 out front, right? Same one, same reason. Again, rules of log say we can do that. So this is 1/4 times the natural log of 3 plus 1/2 natural log of y when you're all done. Expanding. Multiplication becomes addition, division becomes subtraction. Any exponents go out front and multiply by the log. All right, these condensing going the other way. This is addition, so what am I going to do with the 3 and 8? Multiplying, right? Just going backwards. So what's 3 times 8? 24. So that's, you just condensed it. All right, this is subtraction, but I got a 2 out front of that log. So what do I do with that 2? Put it where? As the exponent, right? So the first step is move that 2 out front to the exponent. It's subtraction, so I'm going to write it as what? Division. Division, which means fraction, right? What is 5 squared? 25, right? So I just made 5 squared into 25. It was subtraction, so that's why I made it a fraction. That's division, right? Fraction and division are the same thing, right? Okay. We getting the idea of these?
Yeah.
Okay. The answer to 11 is natural log of 6x to the third when I move the 3 up to the exponent. So then I got to take the 6 and the x to the third power, so that's 216 x to the third. And then I have to multiply 216 times 4 because it's addition, right? So the answer is natural log of 864 x cubed y. Okay? For this one, this problem I'm going to turn into a fraction. All right? And 625 divided by 125 ends up being 5. Okay? So this ends up being log base 2 of 5. Plus, then what do we do with that 1/3? Exponent. That means cube root, right? 1/3. What's the cube root of 27? 3. Good. So then what do I do with the 5 and the 3? Since it's addition, multiply. So it ends up coming out to be log base 2 of 15 when you condense it. Okay? So this is, what number is in front of here? We just don't see it. So that goes up there, right? What number here goes up? And that's for both of them, right? So what both of these make that 9x squared, right? So what is 6 to the negative 1? 1/6, right? So we've got, since this is a 1/6 and I'm subtracting this, that puts that in the bottom. So I got a 6 in the bottom and a 2y in the bottom. I got a 9x squared in the top, and it's a log base 6. Okay? Now, that's 12y, right? What number goes into 9 and 12? 3. So I'm just reducing 9 by 3 and I get a 3. And 12 by 3 and I get a 4, right? So there's the answer. That was a tricky one. You won't get one that difficult on the quiz we have next week. All right, so that's condensing. So that's a quick review of what we did Monday. Okay? We're going to if you guys pay attention. You always do, kid. All right, today we're going to solve exponential and logarithmic equations. All right, so exponential equations are equations in which variable expressions occur as exponents. You can use the following property to solve some exponential equations. This is like what we did when we did these by hand, right? When we were doing without a calculator last week. All right. So what they want us to do is try to write both sides with the same exponent. Okay? You can't always do that. I didn't say that right. Not with the same exponent, the same base. All right, but we can't always write problems with the same base. All right, so I'm going to show you by taking the logarithm. We're going to do it this way. Take the logarithm of each side. That's how we're going to do it. Okay? We're not going to worry about trying to write both sides with the same base. Okay? We're just going to take the log of both sides and use our rules of logs that we've talked about. All right? Again, we're not going to try this way. We're going to do this way. This is the one we want to do. All right? So, we're going to take the log of both sides. So all we're going to do is put log in front. And we're always going to use the common log, the base 10 one, the one that's in our calculator. So we're just putting log in front of both sides. Now, what's the rule we've been working on? Learned it Monday. We went over it today. What can we do with that exponent? We can move it out front and rewrite this as 2x times the log of 3 equals the log of 27. Okay? So we're using that rule of exponents, power to a power stuff, that we can move that exponent out front. Now, I want to get x by itself, so I need to move this log of 3 to the other side. How do I move it over there? Divide it, because it's multiplication, right? So that's the next step. Divide log of 3 to both sides. Now on this side, what happens to both log of 3s? They cancel. That's gone. That's why we're moving it. Get it out of there, right? So now I have 2x on the left. And I think that's a 3 there. Log of 27, close it up, divided by log of 3. Yeah. So that answers 3. So what's the answer to the problem, Emma? You don't know how to get x by itself? Yes, divide by 2. Don't tell me you're not sure. So it's 3 2s, which is what? 1.5, right? Okay. What is 2 times 1/2? 1.5, sorry. What's 2 times 1.5? 3. And what's 3 to the third? 27, right? 3 times 3 is 9 times 3 is 27. So we got the right answer. Okay, so the way we're going to solve exponentials, Collins, is take the log of both sides. All right? Low, you've been paying attention? So, what are we going to do to both sides? Take the log of both sides. Go ahead, do it. Hurry up.
What's his name? Not repeating it again. What's up? Hey, Q. Call me Q.
What's the next step? Vince?
I don't know. I didn't even know to take the login right.
I just told you, so now you know. Now, what did we do on the last one? The next step. You wrote it down, didn't you?
Yeah, it's right here.
Okay. What'd you do with that exponent?
We dumped it
What did we do with the 2x?
2x. On the, like to the left of it.
Yeah, we multiplied it by, we put it to the front. So I got to take the x to the front and the x minus 3 to the front. Because those are both exponents, right? Questions? Mr. Wise, now what?
I'm gonna move log to the other side,
How do I move it?
dividing it.
Yeah, divide log of 100 to the other side. All right, so on the left, all we have is x, and on the right, what's log of 1/10 divided by log of 100?
Nope. 10. Nope. 110.
Negative what? Negative 0.5, is that what you got? You put that in? You put it in just like this, didn't you, Spencer?
Yeah.
You got negative 1/2?
Yeah.
Okay. Do I need to do it? Yeah, that's right. Okay. Now, what do I do next to finish solving this? Multiply what? Yeah, distribute it, right? You guys know what to do from here.
Like up there or back here? It's back here.
Isn't that what you got?
Yeah.
Is it negative 3 times negative 0.5 positive 1.5? Did I do that right? Okay, now what do I do?
That's it.
Add the 0.5, right? You gotta get the x's together. Again, this is just algebra 1 stuff, right? Once we're here, what's 1 plus 0.5? 1.5. Now what?
X equals 1.
Yeah, divide by 1.5, and you get x equals 1. That's solving the exponential equation. So we started out like that. That looks kind of complicated. All right? But when you take the log of both sides, you can move those exponents out front, divide a log over. It doesn't matter which way you go. I always like to take the log on the left over to the right, but we could have taken the log on the right over to the left. It still would work out. And then get our x's alone. You know, we had an x on each side. We got to get them together first, then get the x below. All right? So exponential's not too bad, right? Okay. We still got to do logarithmic, right? Do we need to do this one? No. What's gonna happen when I take the log with that x? Where's it gonna go? Up front. So it's gonna be x times the log of 2 equals the log of 7. So all I got to do to finish is what? Just divide by log of 2, right? And whatever the answer to that is the answer to the problem, right? 2.8?
Yeah.
Thanks.
Thanks, Dave.
Now remember, when you put logs in, it always gives you that left parenthesis. Always close them, right? Make sure you close them. All right, we good on the exponential ones?
Yeah.
All right, we got to do logarithmic ones. Okay? And you guys already have done this, basically. We did this last week on our last quiz. All right, logarithmic equations that involve one or more logarithms of variable expression, you can use the following property to solve logarithmic equations. All right? If you have logs with the same base, which you will, of something equals log of the same base equals something. What must be true about the x and y? They got to be equal. All right? So this example, log base 2 of x, log base 2 of 7, that means x and 7 have to be what? Equal, right? So if you get the same log on each side, you just drop the logs and solve the equation. All right? Now what we're going to do is turn logs into exponentials. Remember we were doing exponentials to logs last week and logs to exponentials? When we do these log problems, we're gonna turn them into exponentials, which you guys were good at. So it's just doing that again. Now, I got the natural log of 4x minus 7 equals the natural log of x plus 5. Those are the same base, right? What is the base for natural log again? E, not 10. 10 is for just plain log, right? So I can just drop these, since they're exactly the same. And there's just one on each side. So I'm going to subtract x to get the x's together. I'm going to add 7 to get the constants together. So I get 3x equals 12. And then x would be 4. Okay? So those are real easy. When you just have natural log or log base 2, log base 2, whatever they are, just drop them. Now, this one isn't the same type. But what is this problem in exponential form? Did it last week. You guys did really well. Remember we had log base 5 of 25 equals 2. What's that in exponential form? Say that again, Nolan. Right. Remember? 5 squared equals 25. So what are we going to say here? 2 cubed equals that. That's all. So the base goes to this exponent equals whatever came after the log. Well, that's an 8. Can we solve that equation now? Yeah, it's really easy. Okay, we're going to do what first? Add 17, which is 25. Good. And then do what with the 5? Divide. So what's our answer? 5. So the exponential ones, we're going to put log in front of them and solve. The logarithmic ones, we're going to turn into exponentials like we did last week. And then solve for x. Simple.